Now we're going to look at simplifying products and quotients with complex numbers. So we're always going to want to simplify completely and make sure that we write our answer in standard form, which is given as a plus bi. We talked about that in the video which came before this. So when we look at multiplying here, we have a binomial times a binomial, and we said that we're going to treat I as though it is a variable x. So we will FOIL. 3 times 5 gives me 15, my first. My outer terms, that's going to be 3 times I. We have plus 3i. My inner terms, that's going to be negative I times 5 is negative 5i. And my last terms, negative I times positive I, that would be negative I squared. So as we move through this problem, we should recognize that we have some like terms which we can combine inside there. So we've got 15 plus 3i minus 5i minus I squared. The 3i and the minus 5i, those are going to simplify to negative 2i. And I still have this minus I squared. This is where it's very important for us to remember what we know about I squared. So this is something we store. We know that I squared is equal to negative 1. So here I have 15 minus 2i, and we have minus negative 1. So minus negative 1 is actually plus 1, and I have 16 minus 2i. That is my simplified form. All right, so pointing out right here where I plugged negative 1 in for I squared, I would expect as an error for a lot of students to give me a minus 1 here, and then this coefficient, we would have 15 minus 1 give us 14. So that'd be a really common mistake. So I just like to point that out and make sure, when you are plugging in that negative 1, write out all of your work. And of course, this is fine as our final answer, but thinking ahead and remembering that we always want to factor, we can notice there's a GCF of 2, and that leaves me with 8 minus I. So either of these would be acceptable. 16 minus 2i is fine, but 2 times the quantity, 8 minus I, that's my completely factored form. All right, let's look at another example. So we're going to do another product here. We're going to simplify this product, multiplying two complex numbers, and again, writing our answer in standard form or a plus bi form. So again, we'll FOIL. Negative 2 times negative 2, that gives me positive 4. Outer, negative 2 times negative 7i, that's positive 14i. Inner, 7i times negative 2, that is negative 14i. And then last, we have positive 7i times negative 7i. That is negative 49i squared. So you'll notice when we look to start simplifying, those two inner terms, positive 14i and negative 14i, cancel out. So that leaves me with 4. And then I have minus 49i squared. Of course, this is where we need to remember what we know about I squared. I squared is equal to negative 1. So we have 4 minus 49, and since I squared equals negative 1, that's times negative 1. So we have 4, that would be plus 49, or just 53. 53 is our final answer. And you'll notice here that 53 is just the real number part. It's just the A part of this imaginary number. Well, what was different about this multiplication compared to the prior multiplication? Why did we get an imaginary number, for example, A, but we have a real number only, for example, B? And hopefully what you notice is that we have two factors and they are identical except for the sign in the middle. So we have -2 plus 7i and -2 minus 7i. Okay, again, noticing the only thing that changed here between each of those factors is that sign in the middle. So what does that mean? What are those called? And why, when I multiplied them, did I get a real number? Factors that are formed like that, where just the sign separating the two numbers in each factor, when just that sign is different, they are called conjugates. And you think about multiplying a difference of squares. And what we can say here is if A plus BI is complex, then A minus BI is its conjugate. Right, so we were multiplying two conjugates where only the sign in between the real and the imaginary portion of that complex number was different. And what we are going to state is that the product of two complex conjugates is going to be a real number. All right? So let's use that logic because we're going to talk about simplifying a quotient of complex numbers. And essentially what we know is we cannot have I or leave an I in the denominator. Here we have a complex quotient and we need to simplify this. What we need to do is we need to make sure that there are no I values existing in the denominator, which obviously the problem comes with. So we need to figure out a way to get rid of I and simplify this quotient of complex numbers. Well, what we can do when we're dealing with a fraction, the only thing that we are allowed to multiply by, which doesn't change the value of the problem, is 1. So I want to multiply by the conjugate, which would be 5 plus I. But 5 plus I is not equal to 1. In order for me to make this so that it looks like 1, I'm going to multiply by 5 plus I over 5 plus I. So again, what I'm doing is I'm multiplying by 1. Anything over itself is equal to 1. And I'm forming that 1 by looking at the conjugate of the denominator. The conjugate means, I have this minus in the original denominator, so I'm going to write my conjugate with a plus in it. All right, so let's look at how we have to simplify this. We're going to need to FOIL the numerator and we're going to FOIL the denominator. I'm going to do that in two separate pieces. So what I have here, I've got 2 plus 3i times 5 plus I, my two factors in the numerator, and 5 minus I times 5 plus I, my two factors in the denominator. FOILing in the top, 2 times 5 is 10, plus, let's see, we've got 2i plus 15i and plus 3i squared. So that's 10 plus 17i plus 3i squared. Of course, we want to remember that I squared is equal to -1. So this is 10 plus 17i minus 3, or rather 7 plus 17i. This is the value that I'm going to write in my numerator. Let's FOIL that product in the denominator. That gives me 25 plus 5i minus 5i and minus I squared. And you'll notice that those two middle terms cancel out, which leaves me with 25 minus I squared plus 5i minus 5i is 0i, or no I at all. So 25 minus I squared is equal to -1. That's 25 plus 1, or 26. So writing my final answer, my numerator was 7 plus 17i, and my denominator was 26. And this fraction, since both of those terms in the numerator are prime and they do not go into 26, we cannot reduce this at all. So this is our final answer here. Of course, you do always want to be looking at the problem and saying, hey, can I factor and simplify? So for example, if we had, 8 plus 16i over 26, you'll notice that all three terms would have a factor of 2, and that would be 4 plus 8i over 13. So we could simplify something that looked like this, or even if we had a situation where 1 was even and say 1 was odd. So in that situation, 8 over 26 could reduce. We could put 2 into each of those numbers. That's 4 over 13. And then that would leave me with 17 over 26i. Okay, so we could simplify in that manner. I'm perfectly fine if you write the fraction as I've listed here in the box for our solution, or you could have written 7 over 26 plus 17 over 26i. That would be a little bit more formal way of writing standard form. And of course, all I was doing over here in the light gray that I've now erased was just showing you, to be careful when you are simplifying those fractions, because you've got multiple terms, and if you're going to cancel a value out of the numerator or denominator and there's more than one term, it has to be a common factor. Just for fun, let's do a couple more examples. Here we are asked to simplify the product of I times 3 minus 15i. In this situation, we just need to distribute. That's 3i minus 15i squared. And of course, we know that I squared is equal to -1. So we have 3i, and that will become plus 15. And of course, I could simplify this, pulling out a GCF of 3. So that would be 3 times I plus 5. All right, and then let's look at one more quotient just to give you guys some more practice. So I wanted to show you this example because we can multiply a monomial I term, a single I term, through this binomial. And one more example. In this situation, we're going to simplify another quotient. We're going to make sure we write our answer in the standard A plus BI form. So what we know when we're dealing with a quotient or dividing complex numbers is that you are not allowed to leave I in the denominator. And we want to multiply by 1, which means something over itself, and we form that one by looking at the conjugate of the denominator, which is 2 plus I. So I have 2 plus I over 2 plus I. Distributing in the numerator, I have negative 2i minus I squared. And foiling in the denominator, we have 4 minus 2i plus 2i and minus I squared. Plus 2i and minus 2i add to 0. So I have negative 2i minus I squared over 4 minus I squared. Now notice I isn't a common factor. We don't have 2 i's in the bottom, so I can't factor an I squared out here and cancel that. So don't make this error and go, okay, well, I can just remove both of those. That would be illegal. What we can do, though, because we know I squared equals -1, I can plug that in. That would be negative 2i minus -1 over 4 minus -1. In the numerator, negative 2i plus 1. And in the denominator, we end up with 4 plus 1, which is 5. So my final answer here would be I'm going to put this into standard form. I'm going to write my real portion first. So that would be 1/5 minus 2/5 I. Of course, this previous step I wrote here, I think that is acceptable as well, but it's just not in that proper standard form. So I hope you feel much better about multiplying and dividing complex numbers. As always, please feel free to email me with any questions or comments because I am here to help. Good luck.